guys explain those Badlands? That's a hell of a name.
Well, welcome Badlands, and welcome all our new watchers as well. This is Space Revolution, and this is episode 8. And the first 7 episodes, we essentially walked through information, energy, and resources in a way that helped people understand what was coming, what technology was coming, and why it was important. So we covered kind of the what and the why, and then talked about our own preparation as a human race on how we can usher this in more peacefully in the future. I'd like to take a little break now and kind of get back to some stuff that's actually a little more fun, and that is talk about the logistics of what's going on, the how. How do we do this? And I think it'll be helpful to everyone because just like back in the 1800s, when somebody was talking about an airplane, they couldn't really visualize what that was, or when they were talking about a phone or a TV, it was like magic and it didn't make much sense. So when I talk about factories in space and manufacturing in space and logistics in space, it's really easy to say, what is that? So today I'm going to take advantage of the fact that a picture is worth 1,000 words. And I'm going to walk you through the logistics of what's going on in space. And I'm going to use the company that I co-founded, SpaceBilt, and what we're doing as a way of describing to you what's happening. Because I think when you hear this, and more importantly, you see it, it'll hit you as, oh, well, that makes sense. There's nothing magic about this. This is real people, real engineers building real logistics infrastructure that makes sense for the future we're going into. This is how all these things can happen when the things we talk about with regard to energy and information and resources. This is how we build it. And you can see the how in pictorial method that actually starts connecting the dots and giving you a visual you can refer back to as we talk in more detail over the coming months and years about the technologies that are coming our way. So that's the purpose of today's show. And as I bring up this video and walk through this movie, I'll pause it and talk to you about what you're watching and what it means. And I think it'll be very instructive. Throughout history, every major civilization that's made a difference, even whether that difference was good or bad, did it by focusing on the economics and the logistics. Whether it was Alexander the Great, the Roman Empire, the Persian Empire, the Ottoman Empire, you name it, the Babylonian Empire, they all sang to the tune of the same drummer, and that is, if you have your economy stronger than your adversaries and your logistics are more affordable and more effective, you will always win the long fight. And when those things degrade, you'll eventually lose. So this is why America has a wonderful superpower called our free market, and the fact that our Constitution allows for free will, and that we talk to one another based on the ideas in our head and the integrity in our heart, not whether you are rich or poor or came from a certain neighborhood or are a certain color or a certain sex. That means nothing compared to the power of the American society to move forward based on the content of your brain and your heart. So let's get right into this. And what I'm going to do is I'm going to go ahead and share my screen. And I'd like you to go ahead and, I have folks watching that can tell me that you can see it okay. So I'm going to share my screen here. And as I share my screen, you're going to see a picture of space. And that picture of space is looking from the inside of a spacecraft, a launch vehicle, a reusable launch vehicle that is opening up to kind of expel the payload that's in the rocket. So I'll go ahead and start playing this, and we'll go from there. The nice thing about this is that we can go through slowly, and you can see this, and then I'll answer the questions as they come in on the chat. so that we are answering your questions as we go as well. So let's start with the play. And so as you watch this open up, you're watching one of our SpaceBilt factories moving into space. And a factory, we'll talk about what this factory is and what it looks like. But essentially, this is an 8 meter by 8 meter, the first instantiation of the first factory. And you think about it this way. This is one of the points I want to make as we take a look at this structure. So this structure is a satellite, meaning that it can work like a satellite. It can maneuver like a satellite. We'll talk more about the maneuvering in a minute. But in days gone by, a satellite, and in fact, even today, satellites are built for one purpose generally, and they are launched up into space. They cost $500 million, and if they're military, they cost even more. And what they do is go up into space and they do that one thing, but they're not looking around. They're not paying attention to what's coming their way. They are not aware of their environment, and they are, in all cases, they are destined to just fall around the Earth at a velocity that keeps them from burning up in the atmosphere or ejecting out into deep space. So they're at the right velocity to just fall around the Earth. Because their trajectory and their movement is predictable, it is very easy to disrupt them. It would be like a boat that you put out into the ocean and you push it in one direction and it never changes course. It's very easy if you cannot maneuver. And so some satellites can maneuver, but if they maneuver, they use up their gas. And if they run out of gas, they were never designed to be refueled. So the analogy I use as you're watching this picture and looking at this satellite can be refueled. So it can maneuver as much as it wants, and we just refuel it if it runs out of gas, versus the analogy of not refueling, not being able to refuel would be like buying a car off a car lot and driving it until it ran out of gas and then burning it to the ground and having to go back and buy another car to get back to your original destination. We do that with rockets in space. This rocket that launched this thing right here is one of Elon Musk's rockets. And he was the one that took a very simple idea, reusable rockets. Because before Elon Musk, every rocket that was built was extremely expensive. And we burned it up in the atmosphere after it took the payload to space. Just a terrible economic decision. And no wonder space is expensive. And no wonder it's a high entry point for businesses. This is all going to change. And my company, SpaceBilt, is going to change it. And this is just a demonstration of how we're changing it. So this, so the way we build a satellite at SpaceBilt is not by putting it together on the planet. The way we do it now, the way most companies build satellites is they have these artisan engineers and scientists that have to put together the entire satellite and then fit it into the tip of a small rocket. Therefore, the satellite that goes up into space is very small, and it has to unfold in space like an origami. And if anything goes wrong with those explosive bolts, the pulleys, and the levers to unfold it and open it up in space, it's a total loss, meaning not only the $500 million that the company spent to build the satellite, but all the revenue downstream that they would be receiving from the telecommunications or the sensors or all the other things that are going on, they would literally not be able to benefit from any of that revenue. So the insurance costs for today's launch methodology are through the roof. SpaceBilt and what you're watching here is a different model, and think about it like Lego blocks. And I'm going to hit play here, and what you'll see is this structure I call a space factory or a garage, a space garage. And in this space garage are robotic arms on the base of this. You can see those robotic arms starting to come to life right now. And what those robotic arms are going to do is they're going to open up the Lego box. And in this Lego box are all the modular elements to build a satellite. Okay. Now that is a new idea. It's a very simple idea, but nobody has ever done this before. And you can make these modular parts and pieces as small or as large as you want. You can qualify them on Earth. So now you do not have to put them together on Earth. You don't have to stuff it into the tip of a rocket. And you don't have all the coupling loads because the ride to space is only about 7 minutes long, and it is extremely violent with G-forces and vibrations that'll pretty much break apart anything. So if my son is building a Lego ship that's very delicate, I wouldn't have him build the Lego ship and then take it on the handlebars of his bike across a rocky road to his destination. I would take the Lego box to the destination and build it. The same is with shipbuilding. Doing shipbuilding the way we do satellites in space would be like building the ship in the Appalachian Mountains and then dragging it to the ocean across rough roads. We don't do that. We build the ship in the location it's going to be operating. And that is what we're doing here with this SpaceBilt space factory or manufacturing facility or garage, however you want to say it. But the top of this factory are the Lego pieces. And we can have dozens of satellites in their component parts, their modular parts up there. And then we can snap together a satellite in a day. Right now, it takes years to build a satellite on the ground because when you build it fully, then you got to wait in line for a vacuum chamber to qualify it in the vacuum of space. Then you got to wait in line for a radiation chamber to prove that it's good for the radiation of space. Then you got to stand in line for a shaker table that gives the G forces and the vibrations to prove that it'll survive launch. And the time and the cost to do that and then re-engineer when it fails those tests is what drives the major cost. And then the insurance cost, because the probability of everything working perfectly, the series of miracles required, is pretty low. But our brilliant engineers do an okay job. In what you're watching right now, all those Lego blocks have already been qualified in space. And we've done that on the International Space Station in years past, as well as in free flight. And we have one of our supercomputers on the south pole of the moon that went up there last year on the Intuitive Machines launch. So you can see that this model where we don't launch a satellite in its full method, but rather just take the Lego blocks that have already been qualified for space use and we put them together in space. And I'm going to show you how the robotics is putting this together because it's very fascinating. So one of the questions in the chat is, has the first space factory been launched yet? And the answer is no. This is why I'm so excited, because our company, SpaceBilt, is one of the leading companies in being able to do this, because our chief technology officer has been qualifying these modular elements for satellite construction for years. And now we're finally at a place where we can do this in space. Elon Musk has a big role to play in this, meaning without his ability to do reusable launch and lower the cost of launch 10x and more, you still wouldn't be able to afford this. So it's equivalent to Steve Jobs could have never invented the smartphone until the government invented the internet first. So Elon Musk has invented this freight train to space where we can launch things to space at very low cost. And now we can build the businesses to do this. So we are very close to doing this. And if we get the right funding by private investors, we will be able to do this within a few years. And you'll start having these factories in space with all these Lego parts. And by the way, the Lego parts that are in the top of this factory, they can be brought up by any rocket. It can be a Falcon 9, it could be a Starship, it could be one of the ones from Stoke or Relativity Space or Rocket Labs. All of these rocket companies that are chasing Elon Musk to get reusable aviation-like access to space at low cost, we can stuff our little pieces and parts in any of those rockets and then store them in our warehouses in space, which is this factory. And once we have the first couple of factories up here, we can now build factories as large as we need. But here's what you're going to see here that's really fun, and that is in space, a factory doesn't have to have walls. And here's what I mean by that. Watch this. This robotic arm, this series of robotics arms are going to take these Lego parts and they're going to build this satellite outside of the factory walls, because there's no need to build it inside the wall. That is something only Earth would require. So I'll pause it here for another question from the chat. And the question is, how heavy is the space factory? Well, here's the other thing that's fantastic about this, and something else Elon Musk has done that most people are not aware of, but will change the game on what you can put into space. Right now, most people in America think that if you're going to send something to space, it has to be extremely light because it's so costly to put it up there. What is unique about the Starship, the big rocket that Elon Musk is right on the cusp of having become operational, is that it is no longer weight limited. It is volume limited. And here's what I mean by that. You could fill his rocket with solid lead and it would still go up into space. What does that mean for engineers? It now means that you don't have to spend expensive money on these light but strong metals that currently populate the satellite population. Every satellite is built with these exquisite metals that are light and strong and very, very expensive. Now you can afford to redesign a satellite and use stainless steel and use metals that are cheap, they're heavier, but you don't care because your stuff will be launched into space at a cost and a price point that is transformational for the logistics infrastructure of space. That is a very great question, and it's a very important point here because now, and this is why SpaceBilt can offer building a satellite for a fraction of the cost of the current satellites being built. Because one, Elon Musk has made it possible to build satellites out of less expensive materials that still have all the attributes to be survivable and sustainable in space. And two, we have the modular Lego parts that we can snap together. The third factor here is something you're watching right now. This robotic arm that just took place, and I'll back it up just a little bit so you can see it a little bit better. But this robotic arm right now is bringing out the engine. This is the cartridge that refuels this satellite we're building. This cartridge is not only the fuel, but also the engine. And when that runs out of fuel, so let's say in 10 years, this runs out of fuel, is this satellite is motoring to the moon and back or going out to service other satellites or do work for some customer. If it starts running out of gas, we just motor a replacement out there, unplug this, just like you would unplug a pellet gun, and it's CO2 cartridge. You can unplug this, plug the new one back in, and take this one back to the garage here for resurfacing and fill it up with whatever fuel. So now you can be agnostic of fuel. We use xenon right now, but we can use just about anything. And this allows engineers to design very creative ways of modular refueling that doesn't have all the danger of what we currently do in the air, where a fighter aircraft comes up to a tanker and there's a hose, basically, that the fighter jet grabs onto, and you pump gas through that hose to the other aircraft. That is dangerous. It requires high pressurization, and it's wrought with potential disaster. There's no reason you can't do it this way, which is a superior idea on refueling. So now what you're going to watch is I'm going to hit play, and you're going to watch this satellite being built in a day from the Lego parts that were in the storage container above this garage. And now you don't have to have the exploding bolts and the pulleys and levers to extend a solar panel. You can do it mechanically with a robotic arm so that you don't have the risk. This is why our insurance costs are so low, because the insurance companies love this, because the probability of this working successfully is huge. And more importantly, even though this is automated and working off AI and machine learning, our engineers and scientists are on the Earth sipping on a cup of coffee in their Oculus Rift, virtual augmented reality, watching all of this happen. And if something happens that's unexpected, they can start manipulating the robotic arms and working to use their creativity and ingenuity to solve a problem, so that you never have a situation where a satellite that's up there in all these Lego parts that's very expensive will be a total loss. In other words, you can fix just about any problem with American ingenuity and engineers that can operate the robotic mechanics and bring in a new part if a part's not working as you test it out. It's just an incredible paradigm change. So here's a couple other questions in the chat. Is there concern about space junk affecting what we're doing in space? Absolutely. Space junk is an issue. Now, space is big, so the big sky theory that the probability is low is there, but we don't rely on that. What is amazing about this, and what I'm going to get to a little later on, is the power of its computer, its brain, its AI cluster computational capability and petabyte storage capacity to be able to do reasoning models with sensors and data so that you can see a piece of space junk coming at you, even if it's the size of a gnat, and you can move out of the way. And or in future years, you can actually have the ability to move the space junk out of your way if you want to. Currently today, the only way of avoiding space junk is if a sensor on the Earth can see our satellite and can see a piece of space junk that's going to hit it. Then we call the satellite owner and say, you need to maneuver out of the way. And the satellite owner is going, well, I will maneuver out of the way, but then that's going to cut 3 years off the life of that satellite because I'm out of gas. And once I'm out of gas, my satellite becomes space junk that's an environmental and operational disaster for other people. This is why this idea of sustainable satellite construction and mobility and refueling is so powerful, because now a satellite will never become space junk again. And, oh, by the way, I'm going to show you how these satellites can go out and grab space junk that's currently useless, bring it back into the factory, melt it down in our forge, and 3D print it into a different satellite or components of a satellite to be reutilized. That's one of the other things we'll talk about as we get through here. So here's another question. What's the Bitcoin play in space? So that has to be from G-Money. And the reality is the economy of space that is going to be a revolution based on what I'm showing you here on how the logistics infrastructure is built is going to require the same kind of resources. And if we don't fix our fiat currency problems in our world, it doesn't matter what economy you build, it's going to be problematic. So this is why all of these things that we are doing as a human race right now to pull ourselves out of slavery and out of the incessant taxation without representation and the economy that has inflation out of control has to be fixed as we go forward into these new ventures and these new places. So that's an important question, and I appreciate you asking it. But G-Money, I love the statement that was made when I had G-Money on this show. Somebody said, G-Money is like a bullet that's been fired, and it's not going to change its trajectory or its path, and but it's going to hit its target. So, okay, so let's keep going here. We were talking about how low the insurance costs are because real engineers on Earth are up here watching this being put together, and if there's any problems, they can manipulate the robotic arms to fix any problem. There's a couple reasons why that's worth staying on that point for a little bit. One, currently our space enterprise is the International Space Station. That was a space station that took billions and billions of dollars to build piece by piece with astronauts putting it together. Okay, we're going to always need astronauts. But right now, if I had an astronaut up here in this factory putting this together, the price tag for an astronaut is $350,000 an hour. And you got to be kidding me. There's no way you can afford that. Only countries can afford that. We are ushering in commercial companies that are just like any other companies that can now afford space capability because of the way this factory and this construction does its work. And we'll talk more about that. But the bottom line is, with laser communications and the ability to literally virtually put the engineer in this factory as the factory is building this, is similar to what surgeons do right now. I can have a surgeon in LA doing surgery in New York City, and the latency or the lack of the small amount of time delay for the speed of light is insignificant. And so we also have techniques for, it's called delay tolerant networks, where you can actually make it even more effective for an engineer to operate and deal with problem solving in an environment where a space factory like this is putting together a satellite like we're watching. So I'll let it play out now, and what you're watching is a satellite being put together in a day. This satellite is going to have multiple customers on it because of the way it's designed with these ports. So I can plug in a customer that is, and I'll pause it here so you can look at this. So this is one of the satellites. This is kind of, I call these robotic mechanics. But this robotic mechanic, this satellite, can motor anywhere in cislunar space. It can go to the moon and back on one tank of gas. It can go out to Mars if you wanted to. It can go to any orbit and service another satellite, or go get space junk. But all these arms you see on this satellite, they can be repurposed, meaning this one is an RF sensor. This one is an optical sensor. This one is a laser communicator. This one is doing an experiment for some high school in Tennessee. This now, because of the low cost of doing the modular elements and putting them together in space, now you can have payload as a service. In other words, in the past, you had to be rich enough to own your satellite, and it did only what you had it to do. Now, satellites are low enough cost that I can rent this space out to a customer that wants to, watch Jupiter for 6 months. And when they're done watching Jupiter and they have the data they need, I can take that payload off and I can put a different payload on there. So now these robotic mechanics, and this one here will build 46 satellites with all the Lego parts in the top of that storage facility. And now this one's going to fly out and start doing work. And here it is. The robotic arms are going to build more. So here's 3 of them flying out to do different missions. So this next segment, I'll show you what kind of missions are important. But keep in mind, these robotic mechanics, so these satellites, have a revenue stream of 6 different customers, but I can design it to have more customers, and it can motor anywhere in space. These are not now ever again required to fall around the Earth as a method for being in space. They can maneuver without regret. Now this is a clipper fleet. It's like the Navy in space. And the only reason we can do that now is because of supercomputing and AI. In the past, every satellite maker and operator just relied on the satellite falling around the Earth because of the nature of orbital mechanics. And when you were in orbit, it took very little fuel to maintain that orbit. That was a very efficient way of doing it when we never refueled satellites. Now that we're refueling satellites, that game is gone. It's a totally different game. And now think about the survivability, where you can maneuver without regret. You are not predictable, so nobody can attack you without you being able to see them. They have the supercomputing to see what's going on around them, and they can talk to one another with the kind of telecommunications, both RF and laser communication that we have. And believe me, in space, laser communication is a game changer. Okay, here's another question from the chat. What agency oversees which country has satellites, where, and is it regulated? So it is regulated. And we'll in fact, in one of the portions of this, I'm going to show you a picture where I'll talk to that issue about, orbital slots. Who owns this slot? Who owns that slot? And so this is the hard part of global geopolitics, and that is every country is sovereign and they can do whatever they want, even if it's against norms. So right now we have a number of accords and treaties: the 1967 Outer Space Treaty and the Artemis Accords that President Trump put together. Very powerful statements about how we should behave and cooperate as countries around the world, and America is going to be consistent with those, with behaving as good neighbors to our friends. But it's also making sure we have the economy and the logistics. So if somebody behaves badly in space, we can not only survive, but prevent them from doing dastardly things in space. So the international community and the standards are part of this journey, but this is why you need a leader in space. Right now, space is the Wild West. There is nothing preventing any country from putting up any capability in space without the values of taking care of Mother Earth and Mother Nature, as well as human nature. So we want to go responsibly into space. And if you don't have a leader like America, designing the rules of the road so that people can operate safely and that entrepreneurs can build business revenue servicing the human race, delivering these things we talked about in episodes 1 through 7, information and energy and resources, the unlimited energy, information, and resources that exist in space. You want rules of the road so that when an entrepreneur takes risk to mine an asteroid to bring trillions of dollars of gold back to the United States or some other country, that somebody can't go in and we can avoid the pirates, the thieves, and the thugs from stealing what good people are building. So we're working on that. That's a geopolitical issue, but it's also an economic issue to regulate this. So common sense and morality define the economy of space. So now I'm going to show you what some of these satellites are going to go do that is going to be really critical, because there's a whole host of missions and we'll only touch on a few. But here, this one, I'll pause here because this one is a picture showing one of these robotic mechanics with 6 different customers, but those could all be, government, they could be private, going to the far side of the moon to see what China's doing over there. Many of you may not know that China is prospecting and mining on the far side of the moon that we cannot see. And we don't know what they're doing. How crazy is that America does not have eyes or ears on what another country is doing in a celestial body that is so precious to the whole human race. There needs to be checks and balances, and we need to see what's going on. This is a Clipper fleet of maneuverable satellites without regret that can now start buzzing around the moon and understanding what's going on and making sure people are behaving morally and responsibly, where rule of law and the norms of the international society are upheld. So that's one of the first missions that we plan on providing with our logistics infrastructure, is the government being able to get out there and see what's going on anywhere in space. Here's one of the satellites that's built for a geosynchronous orbit, meaning this is the one where when you're in this orbit, you're over the same spot on the Earth all the time. So, GPS, for example, is here, and that's why you get good GPS signal anywhere you're at. This is a very efficient way of doing business because you have one satellite that can reach millions of people in one swath of the Earth, and it never moves. It's always above you. It's always watching, and it never blinks. And now you can do that. But here, this next, I'll fast forward to this one. This one demonstrates the modularity of our design, meaning this is a picture of multiple robotic mechanics or satellites snapped together. Okay, and so now, and these have phased array radars on them. That's the mission that this one has. And now, because they're linked together, a phased array radar can be the size of the distance between one edge of this satellite and the other. So the engineers in the audience will understand this. Big aperture and big power, meaning all of these solar panels now are collectively giving you tremendous power. And with big aperture and big power, you can do big things with big return on investment. This is why the satellite dishes you see out in New Mexico are huge, because they are looking out with radio waves into the cosmos, looking for signs of life and understanding what's going on. And they have to be big because in physics, size matters. And so now, but here's what happens right now. These satellites are all snapped together, but this goes back to the question about who regulates this. A company can buy an orbital slot, okay? And in space around the Earth, which is round, there are 360 orbital slots. But when you're out that far, that slot is pretty big, and you only have one little tiny satellite out there, and you're not taking advantage of a large array, a large satellite array that gives you big power and takes advantage of that reality that you could have multiple of these snap-on satellites linked together, and now you've got an aperture that you could never fit into the tip of a rocket. Okay, it would take years, just like with a space station, to build something as big as this. But with our methodology, you can snap these smaller satellites together, and now you have the benefit of a large satellite out of the box. Okay, so here's another question. Does China use actual astronauts or just robots? Well, they use both. And right now we use both as well. But the International Space Station is primarily run by astronauts at $350,000 an hour, which is not cheap. And the reality is China uses robots and people, and we use robots and people, but robotics and AI are changing the game. We are no longer shackled to just using astronauts to do things. with an engineer on the ground, with the kind of dexterity we gain in the virtual and augmented reality of an Oculus Rift or any kind of goggles, and the laser communication to connect them to this satellite or that satellite or any environment, now you can do work that in the past only an astronaut could do. And you can port the human brain and its creativity and its ingenuity to all the sensors we can have in space so they can truly understand what's going on in the environment. It changes the game in cost and speed and in low risk, where we don't put astronauts at risk. We will always need astronauts in space. But as we build out these structures, I'll talk to you about how we can make the environment for the astronauts safe, where they don't have to be bombarded by the radiation that can make them sterile and cause damage to their tissue. And we don't have to expose them to the risk of the heat and the cold of space. Another question is, can you hack one of these satellites? Okay, so this is another component of this that I'm going to get to as we wrap this up, because this is a critically important point. The cybersecurity of doing this work is so critical and so important. And anybody that has a computer or has had a virus or people that try to phish understand this. And so what we are deploying and the core competency is the ability to deliver techniques and technologies that are at the leading edge of cybersecurity, not just with AI and supercomputing, but also quantum hardened, so that we're preparing for when, as quantum becomes more and more mainstream, that we can protect ourselves. One of the major benefits of laser communication is that it is very hard to intercept laser communications unless you get right into the beam. And if you get right into the beam, I can see that you're there and I can turn it off, or just repoint at this altitude of this series of satellites. I just repoint that laser beam, 1 degree, and whatever you're using to try to intercept the beam, it's 100 miles away now, or 1,000 miles away. And I can see you if you're ever in the beam, and I can turn off the data. So it's almost impossible to hack. Nothing's impossible as we move forward, but that simple technique of using laser communications instead of RF makes it really great. But we partner with the leading edge companies in the world that understand security of the cyber and the domain, so that we are minimizing the ability for something to get hacked. And if it is going to get hacked, we can see it and we can mitigate the problem quickly. But this is a cat and mouse game that is my territory as a national security fighter pilot and a defender of our country. All national security is a cat and mouse game. Today I have an advantage, tomorrow you gain an advantage. Tomorrow you have an advantage, I study it, and tomorrow I have an advantage. It is a cat and mouse game, and the trick is, and the reality is, the only security is speed. Speed is life, and if you are faster at innovating than your competition, you win. And that's what we're tapping into at SpaceBilt. Is America's superpower is our free market, and our national security and commercial engineering benches in America innovate faster than anybody, any culture in the planet, because we are culturally innovative in the way we respect ideas and not the color of your skin or what socioeconomic status you have or what the government tells you to do, because we don't work for the government works for us, and we're learning that lesson the hard way right now for sure. Okay, so that was a great question on cybersecurity. I'm going to keep playing this because I want to show you this last scene, and then I want to talk about a couple of books for you to read. Here's another example of the satellites snapped together to create a large, in this case, a transponder farm. So here's the other adaptability and flexibility of this model. You see the satellite to the left. That's one of our SpaceBilt robotic mechanics, or we call it a multi-orbital logistics vehicle because it's not shackled to any one orbit. And we unplugged the sensors and telecommunication portions that were being used by some customer to do something, and we plugged in robotic arms. So you can see 4 robotic arms on this thing, and we're going to motor out to this thing right here on the right. And that is a satellite that was launched by NASA in 1962, and it's now space junk. It's floating out there, and it is, it's a problem because it can't maneuver, it can't see, it's deaf, dumb, and blind. and we need to pull that out of there. And with our robotic mechanic, I can bring that thing back to our garage, and our engineers can pick it apart. If there's a piece on there that's still useful, like that solar panel, we can reuse it. If there's pieces that are not useful, we can melt them down and 3D print them into something. But there are billions of dollars of resources out there in space and all that space junk, and we don't have to throw it away. We can reuse it. So here's an example of one of our factories. And you notice I said factories don't need walls in space, but if you want, you can put a wall on it. Why would you want to put a wall on it? Well, in this case, it's because we have customers that want a data center, or they want a sensor, or they want an experiment from a laboratory, or they want to play with how you can 3D print fiber optic cables with such precision that it's cheaper and can carry 100 times the data at faster speeds than our current fiber optic cable. That's an experiment going on right now. And so the manufacturing that can be done in these factories is going to change the world for people on Earth in all kinds of things. It's not just the engineering technology, it's the medical technology, and it's construction technology, like we talked about in our episode where we talked about construction and resources and building homes in space. So this final picture, though, shows you the agility and flexibility and powerful business case that this demonstrates. So this picture you're looking at right now are multiple of those factories, because every time we launch on one of Elon Musk's rocket, we're going to launch one of these 8-meter by 8-meter factories up there filled with Lego blocks to build satellites for companies all over the world. And if it's not building a satellite with a Lego blocks in its storage hatch, we can take that storage hatch apart and store them somewhere else, and we can snap those factories together. And now this is an assembly line. So now let's say I want to build a James Webb telescope 100 times the size of the one we have now, which you could never affordably do with the International Space Station and satellite and astronauts. It would take years and trillions of dollars. With this model of modular factories that can snap together, now you have robotic arms that are building a certain component here, handing it off to another component, and you have this assembly line to custom build anything you want. And the assembly line is custom built with engineers from all around the world helping to put things together. And when you're done building that thing, all of these snap apart and motor out to do different work. These factories and those robotic mechanics never become space junk. They can become almost infinitely modernized, recapitalized, and upgraded. And when a satellite that you build, because they're modular, when the computer gets so old that it's no longer competing with the leading edge technology, you can unplug it and plug in a new one. So now the current model for space is when you build a satellite, you are stuck with technology for 15 to 20 years before you can afford to build a new satellite. And as we know, Moore's law of innovation innovates every few months. And now if you build a satellite and send it up there, if there's an innovation that changes the business case for your payload as a service or your satellite, all you have to do is send the small little piece that's going to make you effective as a business, and we can unplug the old, plug in the new. It is modular, it is adaptable, it is flexible, it can be remissioned, repurposed almost infinitely. And the stainless steel metal around the frame will last for 1,000 years. So you can see that it changes the entire economy of space in a way that, when you think about it, is actually pretty simple, but that's actually how things happen. Some of the best ideas, the most powerful transformation ideas on the planet end up being pretty simple when you look back at them. But when you're looking forward into the future and nobody has kind of painted the picture that I just painted for you, it can sound like magic. It can sound like science fiction. It can sound like there's no way in hell that will happen. So let me put the final point on this, because again, we could have 100 hours of conversation on each of these things I've touched on as we've looked at the tip of the iceberg on the space logistics infrastructure that SpaceBilt, my company, is building and others are building. And that is that all of this is powered and capable of being done now because of supercomputing. It's the same thing that Elon Musk did. People back in 2001, all the way up till the first reusable rocket of Elon Musk's landed back on the launch pad, People that were some of the greatest scientists of our age said it was impossible. It was a Ponzi scheme, and Elon Musk was just trying to get rich off the government, and it was a waste of our money until he succeeded. And it goes back to a statement you've heard me say before, and I attribute this to many different people, but our chief technology officer for sure, and that is everybody loves innovation as long as it's been done before. And the main point here is that Elon Musk was able to make a rocket that acted like an aircraft, where it took a payload up into space, then came back down and landed on the same launch pad. He refueled it and launched it again. And he's been launching those Falcon 9s many, many, many times over. He was only able to do that by mastering the super computation capability required to thread that needle of bringing that thing back down with enough gas to land without burning up in the atmosphere. We're doing the same thing. That the only way you can do these exquisitely difficult orbital mechanic maneuvers with robotic arms that are changing the centrifugal force of the satellite and creating all kinds of dynamics that are impossible for a human being to handle, a great AI edge computing cluster with current leading edge computational speed and petabyte level storage can not only do it, but it can learn as it's going and get better and better every time it's doing a job, with human beings watching, paying attention, and tweaking when we need to adjust the robotic mechanics or any other activity in the building and the logistics infrastructure and the economy of space. This is why this is possible now, and it was not possible even 5 years ago. And we are on the leading edge of doing this. And so this is the how we build it in order to achieve the what that we talked about in episodes 1 through 7. And I encourage you to go back now and listen to some of those with this visual in mind, because now the idea will become the aha moment, where this is not experimental, this is not difficult, this is already technology that's on the engineering benches today, and all we have to do is put it together and fund the businesses to do this in the commercial market. And believe me, the Department of War is gobbling it up as well and needs it desperately to make sure we enshrine our values in the economy of space. Because when you're talking about a new domain like this, the first person that gets there sets the rules. And I would much rather have American rules of morality and our constitutional norms of rule of law abide in the economy of space than some of the other countries out there that will deceive their people, lie to their people, and punish their people if they don't sing the tune of the government. Of course, in America, we have our own troubles at throwing off the shackles of a tyrant government that's trying to get in our knickers in ways they should never do. But remember, the main goal here of everything we're doing is to put American people back in charge of the government, not the government telling you what to do. You tell the government what to do. That's what we're here for. And that's part of why the space economy is so important, because America needs to lead this, because from space, you can do everything faster, cheaper, and smarter to deliver important things for people on Earth. And if America is not leading this, we're going to have some real trouble in the years to come, and we need to make sure we're paying attention to that. Okay, the other thing I'm going to do here is I'm going to get to a couple more questions here. One is there any way to invest in SpaceBilt? Absolutely. Just go to spacebilt.net or spacebilt.com, and or you can reach out to anybody in Badlands and they can get you in touch with me. But we are always interested in people that want to be on the leading edge of what is coming, not what has been. And we've got the engineers, we've got the team, we've got the idea, and now we're raising the money. We've got the contracts with the Department of War. We've got contracts with commercial companies. I mean, it's really exciting and fun. And, you can always do that. But that is not the purpose of this Space Revolution series. This is about helping everybody understand what's coming and preparing yourself to be the citizen leader of this technology, so it is never used for evil. And it is something that we, the people with the power, are telling our governments and our companies the attributes we want to see in these technologies. So we do this kind to Mother Nature and kind to Mother Earth and the solar system, because I consider Mother Earth and the entire solar system the playground that God gave us to do these things. So today, I'm not going to give you a heavy book like I have in the past, because some of those books are pretty heavy, like Irreducible. I'm going to give you a book that is really fun and exciting. And the book is called, and you may recognize this, Project Hail Mary. It is fun. It is interesting. It talks about the human nature of this journey into space, as well as talking about some of the potentials of how we save our society. It's just inspiring, whether you're a technologist or you're a non-technical person. You're going to love this book, and I'll put it in the notes for this. But I also want to show you the movie coming out, Project Hail Mary. Here's the little ticker for it that you can see. And what I don't know is I read the book many years ago, but I don't know whether the movie is going to be as good as the book, because that book is going to be hard to beat. But that way you have something fun to read that can inspire you, that can make you happy, and help you understand certain components of what's going on here, because the book has its roots in technology, but it is a fictional story about a man in space trying to save humanity. And it's really fun. And it taps into all the things that make us great as human beings. We love one another. We are compassionate. We're humble. We're open-minded. And it tries to throw out all those things that make humanity stumble, where we get our ego and our pride and our arrogance and our envy of others, our fear of missing out, and our insecurities that get in the way. Remember, this space revolution is really first and foremost about reminding us that we belong to one another as a human race. And we want to join arms with all those that believe in our values and move into this great expanse to tap into that gene of wonder and exploration and pioneering and discovery that makes us happy and makes us optimistic. Our better days are ahead, and we're doing this for our future, for our children. And I thank you for being with me on this. We're going to end, normally we try to keep this under an hour, so we're at 55 minutes now. I'll continue reading the chats and answer you individually as we go forward, and address any other questions or concerns in the next one and or on the chat. So thank you for watching Space Revolution. I look forward to seeing you next week, and stay tuned for the next exciting chapter in what's coming to a theater near you. Bye-bye.
Legend says, on St. Patrick's Day, a beard without oil is just a chin with ambition. But a beard with soft disclosure beard oil, that's true treasure. Spiced vanilla, naked, smooth as a leprechaun's getaway plan. Soft enough to impress your barber, bold enough to confuse a baby goat. And this boar bristle brush tames your beard like it holds the crown coin. Every bottle is American made, which means when you buy Soft Disclosure, you're supporting 6 American small businesses. That's not luck, that's capitalism with cheekbones. And while you're at it, try our mint green deodorant, because even legends need fresh pits. Soft Disclosure, go for gold. Visit softdisclosure.com and use promo code TINYBRIGHT for 15% off.
These statements have not been evaluated by the FDA. Promo code does not apply to bundle discounts.
Thank you so much for joining us, and don't forget to hit the thumbs up on this video. And a special thank you to all of our advertising partners. Please remember to shift your dollars to support those businesses that support Badlands Media.